We learned about generation, segregation, collection, and transportation of waste in the previous video. Now let's find out more about how to process this waste and its final disposal. A bird's eye view of the waste management value chain involves 6 essential steps, namely waste generation, segregation, collection, transportation, processing, and scientific disposal. One of the most important steps of waste management value chain is processing and recycling of waste using an appropriate method. This step depends on the composition, quantity, and quality of the waste. The final step is safe disposal of rejects or inerts in a scientific manner. Let's now understand the various methods of waste processing. A constructive way to promote source segregation has been encouraging home composting. If individual households or apartment complexes make it a habit to segregate and compost the wet waste, it will offload a huge task from the ULBs. In return, they will get high quality compost which can be used as manure for the gardens. Availability of various technologies has made this possible, but we still need to know how to do composting at home. It is a fairly simple process. Choose and invest in one of the various available technologies. Install it in a dedicated space in your house. Segregate your waste. Initiate composting process using a suitable accelerator, and within a stipulated time get the final compost. Many large establishments, such as apartment complexes, hotels, shopping malls, institutes, offices, focus on decentralized methods of composting. Variety of technologies allow bulk waste composting for communities to compost within the premises. For the success of the unit level and decentralized level of composting, it is important to generate awareness among the stakeholders and conduct behavior change activities through effective IEC programs and capacity building. Also, ULBs need to adopt mechanisms to enforce, supervise, and monitor the system by engaging civil society organizations. A decentralized approach to waste processing reduces the cost of transportation and the dependency on dumping yards. However, for newly developed cities, decentralized method is being encouraged to follow. However, few bigger cities still continue with the practice of centralized composting due to the large volume of waste generated. In such cases, centralized method is cost effective, requiring less manpower, machinery, and transportation cost. Another decentralized method of processing is biomethanation for the processing of wet waste. Energy from waste is a crucial element of biodegradable waste. Installation of waste to compost and biomethanation plants helps reduce the load on landfill sites. Now let's see how biomethanation works. Biomethanation is the anaerobic digestion of biodegradable waste, which is treated in an enclosed space under controlled conditions of temperature, moisture, pH, etc. In the absence of oxygen, microorganisms break down the organic matter into a stable residue and generate a methane-rich biogas in the process. This biogas can then be used as a source of renewable energy to produce electricity, and the solid residue can be utilized as manure. Before we begin with the dry waste processing methods, let's first understand how is dry waste recovered. Once the wet and dry waste is segregated, the dry waste is stored in material recovery facility and dry waste collection centers. Here, once again sorting takes place. The recyclable waste from MRF are sold to authorized recyclers. The ones fit for processing are transferred to the respective processing plants. The main function of the MRF is to maximize the quantity of recyclables while producing materials that will generate the highest possible revenues in the market. Construction and demolition waste is a new inclusion post the guidelines announced in 2016. These are residues of constructional, demolition, and restructuring activities of civil structures. Although the exact data is not known, but roughly India produces 100 million tons of construction, demolition, and excavation waste material annually. Recycling of construction and demolition waste can help reverse its detrimental effects on the environment and cut costs in producing building materials. Within solid waste management domain, bulk waste generators play a significant role. As per Solid Waste Management Rules of 2016, bulk waste generator includes all gated communities and institutions with an area of more than 5,000 square meter, such as residential areas, commercial establishments, government, public sector or private bodies, social infrastructure, having an average waste generation rate of more than 100 kilos per day. Bulk waste generators need to ensure that the waste is managed and treated within the premises. Urban local bodies play a critical role in monitoring the implementation of guidelines and bylaws set out in the Solid Waste Management Rule of 2016 for bulk waste generators. But what happens when a city doesn't have enough space to install so many processing units? Many cities, hence, have adopted the concept of an Integrated Solid Waste Management Facility or ISWM. ISWM is a comprehensive and effective waste prevention, recycling, composting and disposal technology to manage municipal solid waste, at the same time be economically viable and environment friendly. ISWM facility is the kind of centralized processing facility where segregated waste can be directly brought and treated as per the type of waste. ISWM systems are designed to suit the local needs and conditions of a city. Solid or liquid waste resource management is a community-based model which suits the needs of a specific community and is also managed by them through self-help groups. Now let's see the steps in which SLRM functions. SLRM is beneficial due to its integration of source segregation, promotion of community participation, and implementation of user-friendly technologies. In addition, it provides the opportunity to generate livelihood, especially for women. The last step of processing waste is isolation and disposal of solid waste residue and inert waste in a scientifically designed and controlled facility. This ensures that the waste doesn't seep into the groundwater, nor does it hamper the environment. But what happens to existing dump yards which were not scientifically designed? Corrective actions for dump yards which have been existing for long are being done across the nation. They are treated in a process known as bioremediation. Now let's see how bioremediation takes place. The first step is to excavate a dump, loosen it and make windrows so that leachate can be dried off naturally. Composting biocultures are then added for decomposition. After completely drying, waste is screened through sieves of different size to obtain refuse-derived fuel or RDF and compost. The obtained compost is ready for use and RDF is sent to the cement factories. Through this process, many cities in India have converted the dump sites to recreational spaces. This completes the circle of waste management value chain. Now we know what happens to waste once we throw it in the bin, what a useful resource waste can be, and why waste matters in our day-to-day lives. To know more about innovative practices in waste management, see the next video.